In this video, I'm doing some accessory work with some Zercher squats, single arm planks, and some half kneeling medicine ball slams. And this is going to be the second video in the muscle contraction series. So starting with how we get to the actual contraction, last one we went over the structure. So when a muscle fiber gets activated, it begins with a depolarization signal or an action potential arriving at the cell. When that signal reaches the neuromuscular junction, it triggers the release of acetylcholine, which binds the receptors of the muscle membrane and causes sodium to rush in. This is called the depolarization, and that spreads across the sarcolemma. The electrical signal can't stay on the surface, though. It needs to reach every single sarcomere. That's why the cell has the T tubules. They carry the action potential deep into a muscle fiber. And then that's going to activate the sarcoplasmic reticulum. And that, you kind of think about it like a door. Door opens and calcium floods out of the sarcoplasmic reticulum into the inside of the muscle cell. That surge of calcium is what prepares the contractile proteins to interact. Calcium immediately binds to troponin, which sits on the thin filament. When calcium binds, it causes tropomyosin to shift and allows the myosin heads to attach. Then the cell is fully activated and ready, and the binding sites are exposed. And then the myosin heads will attach. Everything is set for the sliding filament cycle to begin. And that's where the contraction will actually happen. We're going to talk about that contraction in the third video.